So, am I audible to all of you? Yeah, am I audible to all of you? Why so less people are present today? Can anyone please unmute and respond? Why so less people are present today?
Yes, sir. We can hear it, sir.
Yeah, why less people are present today? No idea. So let's wait for first 5 minutes. Then, if no one comes, we'll start eating. Let's wait for 5 minutes and see. Let us start. I hope I can't just call them again and again. So less people. So basically today,
Now we are seeing
what you will see is, you know, SFD and BMD of a cantilever beam. Okay. So let us start with that SFD and BMD of a cantilever beam.
shear force and bending moment diagram for cantilever beam. So here a cantilever beam is given with 3 point loads, that is 6 kilonewtons, 4 kilonewtons and 2 kilonewtons acting at different points on this cantilever beam. So to draw shear force diagram and bending moment diagram, first of all we have to calculate shear forces at different points or locations on this cantilever beam. So here, let us calculate shear force at P. So first of all, to calculate shear force at any point or at any section, let us define what is shear force at any section or at any point. So the shear force at any point is defined, or section is defined as the sum of the forces to the right or left of the section or a point. So here I will start from right side and I'll move to the left of this diagram. So in that case, I am taking all the forces to the right of the point or a section. So here to calculate or to write shear force at the point B. So to the right of B, no forces are there, but exactly at the B, point load is acting. So here the shear force at B will become 6 kilonewtons. And when you take a sign convention for this shear force, so here at any point or section, the when shear force is going clockwise, suppose if you take this is a point A, so about this point, this shear force is going clockwise, so it is positive. Means so when the shear force is going clockwise, it is positive about section, suppose XX section. So shear force is going here, it is going clockwise, and here also it is going clockwise. So it is positive. So friends, to make it easy, and let us, I am taking the shear force which is going downward as positive in a shortcut way. So here the shear force and the force at B, and the point load at B is going downwards. So I am taking it as positive. So here the shear force at B is 6 kilonewtons. And here next shear force at C. So as I told, sum of the forces to the right. So to the right we have 6 kilonewtons and it is going downwards. So it is positive. Plus at C point load is acting. So this point load also we have to take, means it is a all of sudden load which is acting exactly at C. So this also we have to take here. So 6, and this is also going downwards, so it is also positive. 6 plus 4 is 10 kilonewtons with the shear force value at point C. And let us calculate shear force at T. So sum of the forces to the right of T. So here we have 6 going down positive plus 4 going down positive, and here at D, 2 kilonewtons is acting, so it is a point load which is acting exactly at D. So we have to take this also. So it is also going downwards, so it is also positive, so plus 2, that is 12 kilonewtons. So friends, while we are calculating shear force at different points, we can take the previous value, means here we have taken 6 plus 4 and plus 2. So this anyway, the previous value is 6 plus 4, 10, means here the value 10 we can directly take instead of this 6 plus 4, or we can write from the starting value anyway, which is convenient or easy. You can follow like that. So here anyway, shear force at D is 12 kilonewtons, and from D to A there is no force, so the shear force will continue up to A. So the shear force value at A is 12 kilonewtons, and this is also going downwards, so it is positive. So here, to draw this shear force diagram, let us take these dotted lines from all these key points here like this, and here just indicate or draw a line between these two end key points. Draw a line which is indicating the length of the beam, and here to draw the shear force diagram. So start from the right side, and the shear force at B is 6 kilonewtons. So it is a point load. So it is all of sudden load. So to indicate this, we will take a vertical line. So it is positive. So when I have taken the line to indicate the length of the beam, so above line I will take it as positive, and the below line I will take it as a negative. So here 6 kilonewtons is positive, means the shear force at B is 6 kilonewtons, which is positive, and it is a point load. So I indicate with a line, thus that it is indicating all of sudden load. So 6 kilonewtons, I will take approximately this much. So according to that, we have to indicate the other load values. So from B to C, there is no load. So it will continue up to C. So it is horizontal line from B to C. And at C, 4 kilonewtons is acting. So when you take 6 this much, 4 maybe this much. And here, once again from C to D, there is no force. So it will continue. Up to D, and at D 2 kilonewtons is acting, so indicate 2 kilonewtons, and it is also point load, so indicate with the line. And from D to A there is no load, so continue this up to A, and this closes the diagram. So total is positive, so total diagram we got also above the line means, so this will indicate positive. So at B it is 6 kilonewtons, the value of shear force. At C it is 6 plus 4, 10 kilonewtons. And at D it is 12 kilonewtons. And at A also it is 12 kilonewtons. And from the diagram, we can understand that the shear force value at A is also 12 kilonewtons. And this, how we got means, it is a reaction of this cantilever beam at the support. So this 12 kilonewtons indicate the reaction force of all these forces. So that we are getting 12 kilonewtons at A. So next, to draw the bending moment diagram, let us calculate bending moment at different points. So here, first of all, when you will define what is bending moment. Suppose if a force is acting at a point A, suppose force is F is acting, and we require bending moment at some point O. So I require bending moment at O because of the force F. So let us take the distance between these 2 points as D. So I require moment at O because of F. So moment or bending moment is defined as force multiplied by the perpendicular distance between these 2 points, means where the force is acting and where we require the moment. So it is force multiplied by the distance. So this will give the moment or bending moment at that point. So here, when you take or when you want to calculate bending moment at B, so it is force multiplied by the distance. So at B we have force, but at B only we require moment. So B to B distance is 0. So this force means this 6 multiplied by distance is 0. B to B distance is 0. Why? Because we are calculating moment or bending moment at B. So distance is 0. So overall we'll get moment as 0 or bending moment at B is 0. And also here, to calculate or to write bending moment values, we have to follow a sign convention. So, friends, see here. So when a force is bending the beam upward, so it is negative bending moment, which is nothing but hogging. We will take it as hogging, and it is negative. And when a force is bending the beam downwards, so it is positive, and this is nothing but sagging will take. So here anyway it is 0, so it will next when you go for bending moment at C. So here also the definition of bending moment is sum of the moments to the right or left of a section or point. So here at C we are calculating. So we have to come from starting point or starting load. So when you are calculating at C, to the right of C, 6 kilonewtons is acting, and here the distance. So here we require a bending moment at C. So to the right of C we have 6 kilonewtons, and this is the point of application of load, and we require moment at C. So distance between these 2 points is 2 meters. So and also this 6 kilonewtons will bend the beam or the layers of the beam upward direction, so which is nothing but negative moment. So we write here minus 6 into 2. And also here 4 kilonewtons is acting at C, but this effect of this 4 kilonewtons means the 4 kilonewtons cannot create moment at C because C to C distance is 0. That we don't take here. So here total moment at C is nothing but minus 6 into 2 is nothing but minus 12 kilonewton and meter. And next we require bending moment at D. So sum of the moments to the right means moments created by all forces to the right side of D. So here to the right side of D, so I told we have to start from the first point. So 6 kilonewtons is acting here, and we require moment at D. So in between these two, the distance is 2 plus 2, 4. And also this 6 kilonewtons will create negative moment, that is hogging moment. So it is minus 6 into distance is 4. And next this 4 is acting here at C, and it also create hogging moment, so which is negative. So minus 4 into distance in between these 2 points is 2, and here 2 is acting exactly at D. So the moment created by 2 kilonewtons at D is 0 because distance is 0. So we don't write that one. So here this total is minus 32 kilonewton meter. And next we require bending moment at A. Bending moment at A. So starts in the first point. So this 6 kilonewtons will create negative once again about A. So minus 6 into distance is 2 plus 2 plus 1. This is 5. And next 4. So it also creates minus negative moment. So minus 4 into distance is 2 plus 1, 3. And next 2 is there. So it also creates hogging negative moment. So minus 2 into distance is 1. So this total moment at A is minus 44 kilonewton meter. So load value and distance is meters. So these are the bending moment values at these key points. So let us draw the bending moment diagram. So same way, just take dotted lines to indicate the key points here. So to draw the length of the beam here. So draw the length of the beam, and indicate the key points here, A and B, and in between. So this point is C and this point is D, and here also this point is C and this point is D. So here when you see the bending moment value at B is 0 and bending moment value at C is minus 12 kilonewtons. So as I told, we'll take positive above the line and negative below the line. So here at C is minus 12 kilonewton meter and B is 0, means from 0 to minus 12 means downward. So here to draw the bending moment diagram, it will depend upon the shear force diagram. So when you want to draw bending moment diagram between 2 points, so observe the shear force diagram between those same 2 points. So if we have a horizontal line between 2 points, between those same 2 points we'll get a inclined line in the bending moment diagram. And if we have the shear force diagram, if we have an inclined line itself, we'll get same those 2 points, we'll get a curve here, parabolic curve. So here between B and C we have a horizontal line. So in the bending moment diagram we'll get a inclined line, and it is 0 to negative. So the inclined line will be downward direction. So here take a proper scale or proper length to indicate 12, 32 and 44. So I am taking 12 this much. So 0 to 12, and that is minus 12 means negative, downward direction. Horizontal line, and here inclined line. So this is inclined line, and here it is 12 kilonewton meter. And just don't write once again negative here because we have already taken downward direction is negative. And next, from minus 12 to minus 32. Minus 32 is happening at point D. So if this much is 12 and 32 may be this much at D. So minus 12 to minus 32 here. So once again between C and D we have horizontal line. So here we'll get inclined line. Inclined line here. So minus 32 may be up to here. So it is 32 kilonewton meter. And next, at A, we have minus 44 kilonewton meter. So 32 to 44. So 44 maybe this much if you take. So minus 32 to minus 44. So current is 32 to 44 kilonewton meter. So here also between D and A we have horizontal line. So here we'll get inclined line in the bending moment diagram between those two same points. So it is inclined line here, and here close this diagram. So this total is negative here, and it is 44 kilonewton meter. So this is the bending moment diagram for this case. So this way we have to draw the shear force and the bending moment diagram for the cantilever beam with the given point loads. So if you require, you can hash this space also to look the diagram in a neat manner. So you may hatch this diagram. For more videos, please subscribe and activate bell symbol. Thank you. Now,
So I hope this is clear from the video. I'll put on the link of this also. You can just watch it if you want it again. So I think so it is clear for all of you.